So in this chapter, we introduce some words that you've heard before, and I bet that you've heard the word polygon. A polygon is a shape with many sides. So all the shapes that you learned growing up, squares, triangles, hexagons, they're all polygons, shape with many sides. The prefix poly, you'll remember, always means many. Have you heard these words before? Concave, convex? Concave is kind of what I just call caved in, and convex is caved out. Not a very technical definition, but it works. Concave is caved in, convex is caved out. So when we say concave, like this is an example of concave, you see that little caved in piece of the shape, and then this is kind of caved out in every direction. Anything that has a curve on it is not a polygon. So an oval, for example, these are not polygons. Anything that crosses over itself, anything that's like unfinished there, you see that little blank spot, all those are not polygons. But basically the shapes you're used to are polygons. So all polygons, because they have sides, they all have corners. And the vertex of a polygon is just a corner. That's all it is. The vertex is a corner. And then it'll say something like, name the vertices adjacent to C. Do you remember that adjacent just means next to? So what are the two corners next to C? Are B and D. They don't get any symbols, just the letters. Name angles next to angle B. So here's angle B. Actually, this is the angle. Do you agree that the two angles next to angle B are angle A and angle C? Right? Those two angles are next to angle B. Notice that we have the angle symbol there. I'm going to erase it then to start. The next problem is asking about sides. Sides connect corners. So sides are like the edges. They basically connect corners. So these are all the sides. A, B, B, C, C, D, D, E, E, A. Those are the sides. They want to know the sides next to BC. So here's BC. What two sides are next to BC would be these two sides. So side AB and side CD are next to it. Diagonals connect corners not next to each other, so they kind of go across the shape. Connect corners not next to each other. Connect corners not next to each other. So it wants diagonals that start with D, so we would kind of go across the shape, like DB is a diagonal, DA is a diagonal, going across the shape. So chances are you've heard those words before. Vertex is corner, sides connect corners, diagonals connect corners not next to each other. And I am sure that you've heard these words before. How many sides does a triangle have? You are right, 3. How many sides does a quadrilateral have? You are right, 4. By the way, everyone thinks that a quadrilateral is automatically a square. Any shape with 4 sides, a trapezoid, even this concave quadrilateral, anything with 4 sides is a quadrilateral, not just a square. Do you remember how many sides in a pentagon? You are right, 5. And we show like what we consider a regular pentagon, like a normal one, and then a concave pentagon here with 5 sides. How about a hexagon? 6. You may not know heptagon. I don't really use heptagon, but we just wanted to make sure every number was represented. That's 7 sides. I bet you know that octagon is 8, like a stop sign. I bet you could figure out nonagon. Yep, 9 sides. Decagon, I bet you could figure out deca, decade, 10 years, decagon, 10 sides. And so when we say n-gon, it's like n sides. So it's basically like any number of sides. So we kind of sometimes will use that for like 100 sides or something we wouldn't draw. Any number of sides. Now we're going to introduce a word that we're going to use all year long, regular polygon. A regular polygon has all equal sides, all equal angles. All equal sides, all equal angles. So it's like a normal looking shape, right? So a normal triangle is actually an equilateral triangle which has all equal sides and all equal angles. That is a regular polygon. Everyone remembers square because that also has all equal sides, all equal angles, a square. Pentagon here, kind of any normal looking shape, like the normal pentagon, the normal hexagon, and a stop sign here is a regular octagon. So there's nothing to write there, to just observe. Then we are going to officially write down now, I think we've known for some time, that all the angles of a triangle add up to, you are right, 180 degrees. So if this is a 75 plus a 40, I have 115. If I want to find the leftover angle, wouldn't I just take 180 minus 115? And 180 minus 115 is 65. Here I've got a 90 and a 40. Those add up to 130. Or another way to do it is like 180 minus 90 minus 40. If you want to do that on the calculator, that can help you get 50 degrees for the missing side. Oops. How do I get rid of that? There we go. Finally, we have a quadrilateral. So quadrilateral is 4 sides, right? And what we're showing here is that a quadrilateral, if I draw in a diagonal, is really 2 triangles. Every quadrilateral can be split into 2 triangles. And isn't each triangle adding up to 180? So I have a 180 and a 180, so altogether every quadrilateral adds up to 360. So if I want to find the missing angle, I can do one of 2 ways. I can add up like 105 plus 75 plus 113. That's 180. I don't have a calculator here, so I got to do this on my own. 293. And then I would take 360 minus 293, which is 67. That's one way to do it. Add up the numbers you have, subtract from 360. Another way to do it, equally correct, is to take like 360 minus 70 minus 60 minus 125. You might want to do that on a calculator. So that one here I'm doing in my head, that subtracts to 230 minus 125, so that would be what, 105. Either way works, and again, a calculator is probably helpful. Oops, 105. Oh, it doesn't want me to circle it. So there we have it, section 6.1. 6.1.